Okay, in this video we're going to talk about Chapter 3, Sections 5 and 6. Okay, and it mainly deals with slopes and their equations. So we're going to talk about slope here first. Alright, if you notice here I have a line, and the slope of a line is just its rate of change from point to point. Okay, so if you notice I can orient this line any way I want. I can move it up and down and so forth. Now, there's four types of slopes. Okay, one is positive, as you see here. It's a positive slope because as I move from left to right, the slope is going up. If as I move from left to right, the line is going down, that's a negative slope. Okay. And then in between positive and negative, there's a flat line. Okay. And when I go from positive numbers to negative numbers, I must pass through 0. So the slope of a horizontal line is 0. And then the last one is a vertical line. And when I have a vertical line, the slope is undefined. It has no slope. Okay. Now, how do I calculate slope? Okay. We calculate slope by using the points. All right. So I have A here, and A is at point 6, 2, and point B here is at point -3, -4. Now, the slope here says AB is 0.67. Well, 0.67 is really 2/3. All right. Now, in order to calculate slope, I need to put the rise over the run. So the slope is equal to rise over run. Rise is the change as it moves up and down. Run is the change as it moves left to right. So the equation would be the y2 coordinate minus the y1 coordinate over the x2 coordinate minus the x1 coordinate. So I'm going to say that this is the second point and this is the first point. So when I plug in, the y2 point is 6 minus, this is a -4, so that's -4. Okay, over the x2 coordinate is negative, or excuse me, isn't negative, it's 6 minus -3. And I plug in and I simplify. 2 minus -4 is 6. 6 minus -3 is 9. 6 over 9 reduces to 2/3, which is the exact slope that I have here. So given 2 points, you can find the slope of a line. Okay? Remember, rise, it rose 1, 2, 3, 4, 5, 6. It ran 1, 2, 3, 4, 5, 6, 7, 8, 9. 6/9. Okay? So that's how we can calculate slope using 2 points. All right? Also, if I calculate it and the slope ends up being 0 over a number, so let's just say I'll just use this to represent a number, and that means the slope is 0. If I ever get a number on top and 0 on the bottom, then the slope is undefined. All right. So our first theorem here, 3, 5, 1, our parallel lines theorem. In a coordinate plane, two non-vertical lines are parallel if and only if they have the same slope. Two vertical lines are always parallel. So if I look here, I have line AB and I have a line J here. The slope of AB is negative 0.43, so it's a negative slope. The slope of J is negative 0.43. So since they both have the same slope, these lines are parallel. So same slope, lines are parallel. Okay. All right. The 3, 5, 2 theorem, perpendicular lines theorem. In a coordinate plane, two non-vertical lines are perpendicular if and only if the product of their slope is negative 1. So the vertical and horizontal lines theorem. So the slope here of BC is 2. So that means the slope of line AB should be negative, because when I multiply these two slopes together, they got to be negative, and they have to equal 1. So the opposite of the reciprocal of 2 is 1 over 2. So I simply flip the slope and change the sign. All right, so let's calculate that. So I'm going to point here, construct point, line, construct perpendicular line. Okay, there's the perpendicular line, and I'm going to ask for the slope here. Slope of J is negative 0.5, and if I take the slope and multiply it by the other slope, I get negative 1. So these are perpendicular. Also, when you make a perpendicular line here, that means that this is a right angle. So the distance from point A to BC is the distance from A to where they intersect, right here. So I can create a perpendicular line from a point using the slope and find the distance. So it would be whatever the distance from A to this point. So A to D. Okay. All right, 3-6. 3-6 is writing equations or lines in coordinate plane. Okay, there's two forms that we use, okay, for a slanted line. Okay, one is slope intercept. And that's y equals mx plus b. So I have a line here. I'm going to measure its slope. Okay, the slope is 1.5. So slope of 1.5 is really y equals 3 over 2. I could put 1.5 here, but that's all I like to put the fraction. And then the b represents the y-intercept. Well, the y-intercept here, I've marked it for you, is negative 4. The y-intercept is always where it crosses the y-axis. And it crosses the y-axis when x equals 0. So negative 4 is my y-intercept. So there you go. I plug it in. Y equals 3 over 2x minus 4. That's the slope-intercept form of this equation. Now, the other form is point-slope. Now, point slope form, I take y and I subtract y1, and that equals m times x minus x1. y1 and x1 are just any point on the line. So I'm going to use this point here, point A, and I'm going to plug in. So y minus 5 for the y value equals, the slope is the exact same, 3 over 2 times x minus, and then 6. So this is one form for point slope. I could have picked any other line, or any other point, excuse me, on the line, and it would give me an equation for this line. Now if I took point slope form and solved for y, I would get y equals 3 halves x minus 4. It would become slope intercept form.